And now let's use the slope-intercept form to determine the equation of the line for each one of these graphs that we're given. Notice that you're not given any points on the graph, but you do know a little bit of information. You know, you probably notice that B is a horizontal line. You have C and D, both have negative slopes. The line is going down to the right. A has a positive slope. The line goes up to the right. If you look at y-intercepts, A has a positive y-intercept. B has a positive y-intercept. C has a negative y-intercept. D has a positive y-intercept. And that's really all you have to know to come up with the equations for these lines. So let's start with A. On A, we know the line is going up to the right, and so it has a positive slope. So choice A has a positive slope. B and C are special lines, horizontal and vertical lines. D has a negative slope. So let's see, E has a positive slope. So A and E are the lines that have positive slopes. And here the y-intercept is above the origin, so the y-intercept is positive. So I have a +3 for A, a -3 for E, which means that A gives me matches the graph A. Equation A and graph A match. So move that over. And let's look at B. B is a horizontal line. And so if I look at equation B, x equals 3 is a vertical line. It'll be right about here probably. Y equals 3 is a horizontal line. And you have a positive y-intercept. So C, equation C matches graph B. Okay, so C and D both had negative slopes. And the equations with negative slopes are D, F, and G. On equation D, you have a positive y-intercept. So that's going to match up with graph D. Equation E has a negative y-intercept. So that's going to match up with graph C. And then F has a y-intercept of 0. If the line would have gone through the origin, then F would have been the equation. Oh no, so anyway, graph G has a negative slope and a negative y-intercept. And then graph D had a negative slope and a positive y-intercept.